Before we plunge into the declaration, it's critical to comprehend what molecule accelerators are. The Large Hadron Collider, LHC, operated by CERN, is a 17-meter ring of superconducting magnets and the world's largest and most powerful atom smasher. It represents the zenith of human scientific achievement. In fact, it's so powerful that it can recreate the physical conditions of the universe's birth. But could this machine, designed to unlock the secrets of the universe, hold the key to something far more ominous? CERN, established in 1954, is one of the world's most prestigious research organizations. With 23 member states and thousands of scientists, it's a hub for collaboration and innovation. The LHC is CERN's flagship project, but it's just one piece of a vast network of accelerators and experiments. Imagine a circuit, not for cars or horses but for subatomic particles, engaged in a race through time and space. The LHC accelerates protons to nearly the speed of light, sending them on a collision course that replicates the energy of the universe at the time of the Big Bang. These collisions create temperatures over 1,000,000 times hotter than the core of the Sun. Thousands of magnets guide the protons on their journey, while complex cooling systems keep the magnets at temperatures colder than outer space. The beams inside the LHC collide at 4 points around the accelerator ring, corresponding to the locations of 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each serves a unique purpose, exploring different aspects of particle physics. Together they act as giant cameras, capturing snapshots of these collisions. Scientists then sift through the debris, searching for traces of the elusive Higgs boson, also known as the God particle, and other phenomena that offer clues about the fundamental building blocks of the universe. By studying the microcosm, we gain insights into the cosmos. Yet with every answer comes another question, and with each discovery, a new challenge. The LHC isn't just a scientific instrument, it's a testament to human curiosity and innovation. It embodies our relentless pursuit of knowledge and our desire to understand the fundamental forces that shape our universe. But as we push the boundaries of what we know, we must also consider the ethical and existential questions that arise. What are the risks of exploring the unknown? Could our quest for understanding inadvertently unleash forces we cannot control? In the hallowed halls of CERN, where the limits of human comprehension are constantly tested, a discovery has emerged that sends a chill down the spine of even the most seasoned scientists. Brian Cox, a former researcher at CERN and an authoritative voice in the world of particle physics, recently made a statement that has left the world both fascinated and fearful. Cox's words resonate with haunting clarity. The goal of CERN's Large Hadron Collider is to recreate a small Big Bang. Yes, you heard that right, a miniature version of the very event that gave birth to our universe. The physicist went on to explain the implications of this goal, highlighting the LHC's extraordinary potential for groundbreaking discoveries. This includes its ability to unlock the secrets of the Higgs boson and explore dark matter, a mysterious substance that constitutes a significant portion of the universe. Imagine wielding the power of creation, the ability to summon the very essence of the universe. It's an enticing prospect, but one fraught with danger. The miniature Big Bang is not a theoretical concept, it's a tangible reality within the LHC. The temperatures, pressures, and raw energy all mimic the conditions of the universe's infancy. It's like standing at the dawn of recorded history, witnessing the birth of existence itself. But with such power comes responsibility, and the question looms: what if something goes wrong? In fact, something did go wrong back in 1978. Russian physicist Anatoly Bugorsky experienced a calamity that would forever alter the course of his life. While working on the UB-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a malfunction caused his head to inadvertently come into the direct path of a proton beam. The beam, with unimaginable force, passed through his skull, entering the back of his head and exiting through his nose. Bugorsky's experience was miraculous. He saw a flash brighter than 1,000 suns yet felt no pain. The beam's path left a trail of destruction, burning through tissue and bone, yet he remained conscious and even walked to the clinic for treatment. The aftermath was both terrifying and fascinating. The beam's path caused localized tissue death, resulting in loss of hearing in one ear and partial facial paralysis. Yet, incredibly, Bugorsky's intellectual abilities remained intact, and he continued his scientific career. This incident is not merely a personal tragedy but a cautionary tale that underscores the immense power and potential danger of particle accelerators. The risks of an atom smasher like the LHC are not to be taken lightly. The potential for unforeseen reactions, the manipulation of the very fabric of reality. These are not the stuff of science fiction but genuine concerns voiced by some in the scientific community. One of the most alarming and captivating concerns associated with the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are cosmic vacuum cleaners, devourers of stars, and enigmatic entities lurking in the shadows of our universe. The idea that the LHC could create such an entity, even on a microscopic scale, is both thrilling and terrifying. Could this black hole grow uncontrollably, consuming the Earth from within? While scientists at CERN have assured the public that any black holes created would be unstable and dissipate quickly, the mere possibility has ignited debates, fears, and a sense of awe at the power we wield. It's essential to understand how the LHC could create a black hole. It involves the fundamental mechanics of particle accelerators. When protons collide at nearly the speed of light, the energy released is so immense that it warps the fabric of spacetime itself. Imagine a trampoline stretched tight, and then a heavy weight is dropped onto it. The fabric bends and stretches, and if the weight is heavy enough, it could create a depression so deep that anything nearby would be drawn into it. That's a simplistic analogy for what could happen in the LHC. In the realm of quantum physics, where the laws of the universe are both unpredictable and beautiful, there exists a theory that additional dimensions may be hidden within our universe. If these dimensions exist, the LHC's collisions could tap into them, creating a gravitational funnel that forms a microscopic black hole. This mysterious dance of particles has even caught the attention of world-renowned scientists, particularly the late Stephen Hawking. In his book, he warned of a scenario where the Higgs boson could become shaky at exceptionally high energy levels. This dependability could prompt a horrendous vacuum rot, an enormous occasion that wouldn't just obliterate the Earth but the whole universe itself. The regarded English cosmologist and astrophysicist Sir Martin Rees also communicated his concerns about the trials conducted at CERN. In his book on What's in Store, Possibilities for Mankind, he explored the potential dangers associated with atom smasher tests, including those at CERN. His words were not just preventative, they were tinged with a sense of existential fear. He discussed a worst-case scenario where a doomed experiment could create a condition called vacuum instability. This instability could, in theory, set off a phase change that would echo through the very fabric of spacetime, resulting in a cosmic catastrophe that could engulf the entire universe. Rees's concerns were not limited to theoretical ideas. He assigned a probability to these devastating outcomes, albeit a low one. Yet, even a minute chance, he argued, should give us pause. The stakes are incredibly high, and the margin for error is razor-thin. The scientists at CERN have calculated the probabilities, run the simulations, and analyzed the theories to argue for the safety of the Large Hadron Collider, LHC. In fact, Brian Cox himself acknowledged the importance of careful scrutiny, recognizing that there are widespread fears and concerns surrounding the activities of the LHC. He emphasized that rigorous safety measures, extensive reviews, and protocols ensure the LHC's operations are conducted with utmost caution. Cox reassured the public that the energies involved are well within what the Earth naturally experiences, and the chances of creating a stable black hole are astronomically low. Even if one were created, scientists say it would be so small and unstable that it would vanish in an instant, a phenomenon predicted by Stephen Hawking known as Hawking radiation. It would be a fleeting moment of cosmic wonder, a glimpse into the void, and then gone. Some have gone further, speculating that the LHC's experiments could open a portal to another universe or dimension. This idea, though largely dismissed by the scientific community, has captured the imagination of many and become a topic of intrigue, fear, and even folklore. What lies beyond our reality? Could we inadvertently unleash forces or entities we do not understand? The idea of opening a gateway to hell has even been dramatized in various media, fanning the flames of uncertainty. But how did this idea arise, and what does it mean in the context of scientific exploration? The concept of parallel dimensions isn't new in physics. String theory, a leading candidate for a unified theory of everything, posits that there may be more than the familiar three dimensions of space and one of time. These extra dimensions could be compactified or hidden from our perception, but they could theoretically be accessed or revealed under extreme conditions. Now imagine the LHC as a cosmic key, unlocking doors that have been sealed since the beginning of time. When protons collide at energies never before achieved on Earth, they could, in theory, create ripples or vibrations that probe these hidden dimensions. It is the stuff of science fiction, yet it has a basis in the mathematics of string theory. Could we unknowingly open a door to another world, or worse, unleash something beyond our control? So, what does this all mean for humanity's future? Should we abandon our pursuit of knowledge out of fear of the unknown, or should we forge ahead, understanding that the quest for discovery is both a privilege and a responsibility? The questions raised by the LHC's experiments are vast and profound, and the answers will continue to shape our understanding of the universe and our place within it. One thing is certain. The LHC has the potential to change everything we know about the universe and our very existence. Yet, with that knowledge comes a sobering realization. Some things are best left unseen. As the LHC continues to push the boundaries of our understanding of the universe, its very existence serves as a reminder of the double-edged nature of human curiosity. While the pursuit of knowledge and discovery is noble, the uncertainties associated with particle accelerators like the LHC challenge us to reconsider the balance between scientific progress and the potential risks involved. The excitement surrounding the LHC is not just about unraveling the mysteries of the universe but also about confronting the deepest fears of what could go wrong. One of the fundamental questions raised by CERN's experiments is whether humanity is prepared to handle the consequences of these discoveries. The LHC's primary goal, to unlock the secrets of the universe, relies heavily on exploring quantum physics, an area that defies intuition. As we strive to understand the very forces that govern existence, scientists are increasingly discovering that the principles of classical physics no longer apply at the quantum level. This strange world of subatomic particles operates according to probabilities rather than certainties, making predictions difficult and adding to the inherent risks. In fact, one of the most fascinating outcomes of the LHC's research has been its investigation into quantum fluctuations, tiny, seemingly insignificant disturbances in the vacuum of space that can give rise to phenomena never before observed. One such concept that has come to the forefront is quantum tunneling, where particles can pass through barriers that, according to classical physics, they should never be able to cross. In a way, this mirrors the uncertainty and unpredictability surrounding the work being done at CERN. It is a reminder that while we can observe and measure these tiny particles with incredible precision, the outcomes may still be governed by forces we do not fully understand. Yet, as unsettling as the risks may seem, the allure of discovery and the potential to answer questions that have lingered for centuries cannot be denied. The study of dark matter, for instance, could revolutionize our understanding of the universe. Dark matter makes up about 85% of the universe's mass, yet it remains invisible and undetectable by current instruments. The LHC's experiments, with their ability to manipulate particle collisions at extremely high energies, could provide the breakthrough physicists have been waiting for, possibly offering the first tangible evidence of this elusive material. However, there are those who believe that the drive for discovery may be clouding our judgment. Critics of the LHC often point out that while the potential benefits are exciting, the risks could be catastrophic. One of the most troubling aspects of the LHC is its ability to create conditions similar to those that existed in the moments following the Big Bang. If a tiny black hole were to form, it could lead to unpredictable outcomes. While scientists insist that such a black hole would evaporate instantly, some argue that we cannot be so sure. The idea that we could recreate the extreme conditions of the early universe comes with a grave responsibility, and a fear that humanity's ability to control this power is still very limited. The LHC's potential to create extraordinary phenomena isn't limited to black holes. For instance, there is a concept known as the multiverse, the idea that there may be an infinite number of parallel universes, each with its own unique properties. Some have speculated that the experiments at CERN could give us a glimpse into these other universes. While this remains highly speculative, it highlights the broader implications of the work being done at the LHC. What if we could somehow connect with or even manipulate these alternate realities? The very thought sends a shiver through both the scientific community and the public. Additionally, there is a broader ethical question that arises from all of this. Should humanity seek to push the boundaries of scientific understanding without fully knowing the consequences? As with any great power, there is the risk of misuse, whether intentional or accidental. Throughout history, humanity has made discoveries once thought impossible, from nuclear energy to genetic engineering. While these breakthroughs have led to tremendous advances in medicine, technology, and energy, they have also brought unintended consequences, some of which have been tragic. In this light, the work at CERN may be a harbinger of both the promise and peril that comes with scientific progress. It demands that we consider whether the pursuit of knowledge, no matter how noble, is always worth the potential costs. The LHC represents not only a monumental challenge in particle physics, but also a metaphor for humanity's broader quest to understand our place in the universe. And as we delve deeper into the fabric of reality, we must ask ourselves, what are we prepared to risk in the name of discovery?